Hi, I'm Gracie Borgelt, and I'm an 8th grade student at St. Rose in Perrysburg. My project is on the levels of microplastics found in different locations in the Lake Erie watershed. I chose to do this project because Lake Erie is a large source of drinking water for people in my area. While doing my research, I learned that microplastics can have a very dangerous impact on the human body. I took water samples from Catawba State Park, which was Lake Erie, Maple Street Docks, which was the Maumee River, Sidecut Creek, which was a tributary to the Maumee River, and the sink in my science classroom. And these are just some maps from where I took my samples. So this was Sidecut Creek, and this was the sink in my science classroom, and this was Maple Street Docks. And on this one you can see that is where I took my sample for Lake Erie. It just doesn't show on there because that's too small. So here's just some background information. Microplastics are plastic particles less than 5 millimeters in length. Microplastics can be found in a very large variety of everyday household items. The average adult consumes about a credit card's worth of microplastics per year, and microplastics can lead to problems such as petroleum poisoning, death, heart attacks, stroke, and cancer. Water is a necessary part of life, so if it's polluted with microplastics, there can be a very adverse effect on the human health. My research question was, how do microplastic levels vary throughout the Lake Erie watershed? My hypothesis was that Lake Erie would have the highest level of microplastics because I found in my background research that scientists had done tests on the Great Lakes and found that there were a lot of microplastics in them. So my independent variable was the location from which I took my water samples, and my dependent variable was the amount of microplastics in each sample. For my controls, I took my water samples within 48 hours of each other, used the same size glass mason jars to hold the water samples, washed out the filter unit with distilled water before each testing, and put the pieces of filter paper after testing in identical petri dishes. Unfortunately, I was not able to repeat this experiment because I was limited in the number of pieces of filter paper available to me. So for my materials, I used glass mason jars, the microplastic filter unit, water samples, 0.47 micron filter paper, petri dishes, tweezers, safety goggles, a pH tester, distilled water, turbidity tube, parent's phone, thermometer, black masking tape, black rubber tube, air pump, and brass fasteners. So first I spoke to Mrs. Tracy Ostrom, who works at UC Berkeley. She was able to send me the microplastic filter unit, which I'll talk about in a moment, and she gave me some instruction on how to use it. And then I completed background research, and then I took my water samples at Catawba State Park, Maple Street Docks, Sidecut Creek, and the sink in my science classroom. I took the temperature of the water and the turbidity of the water and then recorded that in my notebook. I took note of weather conditions, and then I let the samples, as you'll see here, settle for at least 2 weeks so that all natural debris could fall to the bottom. So here are just some pictures. This is taking water samples at Maple Street Docks, Catawba State Park, and Sidecut Creek. So this is the microplastic filter unit setup. So first you had to wash out the upper and lower chamber of the filter with distilled water. And then you would mark filter paper, such as like these, with an X and a Y axis so that you could look at it under the microscope. And then I put the the filter paper in the middle of the filter unit using tweezers or brass fasteners because I didn't have tweezers. And then I screwed the upper and lower chambers together with filter paper in between. And then I attached the vacuum system. And I'll show the slide for that. So this is the filter unit. So the vacuum system is the black rubber tube, and that connected to the lower chamber. That was connected to an air pump, which would suck water out of the lower chamber, creating a vacuum for the water in the upper chamber to run through. I poured exactly 500 milliliters of water into the upper chamber, and then I screwed the lid back on top to seal up the filter unit. I turned on the air pump and let let it suck out the air, and then the water would run through. And then when all the water had gone through, I unscrewed the upper and lower chambers and removed the filter paper from in between the upper and lower chambers using tweezers or brass fasteners. I placed the filter paper in a petri dish, and I used masking tape to label the petri dishes. I repeated the steps for each of my water samples, and then I looked at the filter paper under a microscope at four times magnification, and I drew a diagram of what I saw in my notebook. And then I repeated this for all of my samples. So this is what I saw this is just a drawing of what I saw. The first one you'll see is the sink in my science classroom, and the next one is what I saw in Lake Erie. And I kept track of the microplastics in each quadrant. And this is from Maple Street Docks inside Cut Creek. You'll see it's pretty much the same, just quadrant, different microplastic levels. Oops. So this is my microplastic table. Note that all samples were per 500 milliliters of water. So in Lake Erie, I found 18 microplastics. In the Maumee River, I found 24. In the tributary, I found 20. And in the sink in my science classroom, I found 18 microplastics. So here's just some extra information that I took, like pH, weather, water temperature, air temperature, humidity, wind, and turbidity average. I'll talk about this a little bit more. So here's my graph. I used a bar graph because I just wanted to show the difference between the different levels, and I thought that this was the best way. So it's just the same information as I had in my first table, just a visual diagram. And then my statistical analysis. For the mean, there was an average of 20 microplastics per 500 milliliter water sample, a range of 18 to 24 microplastics, a standard deviation of 2.8 microplastics between the samples, and I also did correlation coefficient, which shows the relationship between two variables. For the pH and microplastic levels, there was a standard deviation of 0.354, which showed that there was a weak positive relationship. This meant that as pH increased, so would the microplastic levels. Between turbidity and microplastic levels, there is a negative 0.8245 relationship, which meant there was a strong negative relationship. Turbid is typically used to describe how murky, when water is really murky, but you take turbidity by pouring water into a tube and letting it out until you can see the bottom. So higher turbidity measurements, because of how I took the turbidity, indicate clearer water. So this basically just means that as the water becomes more clear, the less microplastics there are going to be. And there was a negative relationship between temperature and microplastic levels. So as temperature decreased, so would microplastic levels. So here's my discussion. I did have a few problems. I've never really worked with microplastics before, so I had trouble telling if a particle was a microplastic or not. And I was unable to take more than one sample due to limited number of pieces of filter paper. I learned that microplastics pose a major threat to the health and safety of our world today. And I liked being able to bring awareness to a problem that is really important in today's world. My hypothesis was not supported by my results. Lake Erie was actually tied with the sink in my science classroom for the least number of microplastics, 18. The Maumee River had the greatest number of microplastics at 24. I believe that this is because the Maumee River is a lot more turbid than any of my other samples that I took. If I were able to repeat this experiment, I would like to take multiple water samples on different dates from each of my different locations. I would also like to learn more about the different types of microplastics so I could better identify them. I would also like to do a project that specifically looks at how water quality impacts microplastic levels. I would like to say thank you to Mrs. Tracy Ostrom for providing me the microplastic filter unit. Thank you to my parents for taking pictures, driving me to sample sites, and helping me use the filter unit. And thank you to my science teacher, Mr. Les, for arranging me to borrow the filter unit and helping me set it up. And then here are just the resources that I used. Thank you.